Hello everyone, I am Stavros and I will be presenting our work on efficient multi-frame defencing. Taking photographs with cell phone cameras in the wild is often hindered by various types of obstructions such as reflections, rain, fog, or fences. These obstructions are hard or impossible to avoid, so removing them automatically from photos is a computer vision application of increasing interest in the last few years. In this work, we specifically focus on the task of fence removal because of how common this type of obstruction is and because of the particular challenges it poses, such as repeated patterns that span the entire image. A straightforward defencing solution is to first segment the fence and then inpaint the corresponding parts of the image. Multi-frame approaches like SOLD offer improved quality by consolidating information from an input burst of keyframes, but involve complicated CNN architectures with an increased computational cost. We design a multi-frame, state-of-the-art defencing pipeline that is an order of magnitude faster than competing approaches. To achieve this, we adopt a core idea from the video completion literature, that inpainting occluded optical flow maps and using them to warp occluded pixel values from temporally neighboring frames is an easier task than directly inpainting missing RGB values in the obstructed area. Given a burst of keyframes with fence obstructions as input, our algorithm reconstructs a single keyframe after removing the fence. Our pipeline is composed of three distinct steps. Initially, a fence mask is estimated on each input frame individually with a unit segmentation model trained on fence segmentation data. The estimated masks are used to condition a modified segmentation-aware spine net, which simultaneously computes and inpaints flows corresponding only to the background scene. We train this network to ignore the repeated fence occlusion patterns, which has been a main challenge for previous works that use off-the-shelf flow estimation networks. Finally, an image inpainting module uses the estimated flows to align the frames and masks with respect to a selected keyframe and fills in the missing pixel values. One challenge we face is the lack of defencing burst datasets with corresponding ground truth. To quantitatively evaluate the performance of our algorithm and compare with other baselines, we collect a dataset of real-world handheld sequences with a fence and a corresponding background ground truth image without a fence. As we cannot physically remove a fence, we instead center our camera in one of the fence cells such that only the background is visible, and align patches from the obstructed and unobstructed images to generate a total of 185 bursts and corresponding ground truth keyframes. The results in our real burst dataset are telling. Our system processes a single 5-frame burst at 7 frames per second, which is approximately 10 times faster than the second best performing methods. At the same time, our method significantly outperforms methods with more comparable runtimes in terms of reconstruction accuracy. And here is a qualitative comparison. Our method offers better reconstruction quality than costlier multi-frame pipelines such as SOLD. Llama, a state-of-the-art single-frame inpainting algorithm, produces plausible but inaccurate results. Notice the single instead of double railings, confirming the benefits of multi-frame inputs. Finally, some video completion methods completely fail for short input sequences. Thank you for your attention. For more details and results, please visit our poster.